Imagine a vast, silent ocean of darkness, so far from home, that the sun is nothing more than a particularly bright star in a crowded sky. Out there billions of miles away, where the heat of our solar system finally loses its grip against the freezing void of interstellar space, something remarkable is happening. For decades, we thought we understood the boundaries of our neighborhood. We pictured a clean exit, a transition from the sun's influence into the great unknown. But NASA just released data from its most distant explorers, and the results have sent shockwaves through the scientific community. There is something lurking at the very edge of our solar system, a physical structure or phenomenon that possesses no scientific explanation and defies the laws of physics as we currently write them. We aren't just talking about a strange rock or a weird gas cloud. We are talking about a massive, invisible wall of pressure and fire that seems to be acting as a gateway to the rest of the galaxy. Today, we are diving into the data from Voyager 1, Voyager 2, and the New Horizons mission to uncover the mystery of the hydrogen wall and the ribbon of the heliosphere. This is the story of how our solar system just got a lot more crowded and a lot more mysterious than any textbook ever dared to predict. To understand why this discovery is so earth-shattering, we have to talk about what we thought was out there. Space is often described as a vacuum, but it's actually filled with stuff. Our sun is constantly screaming out a stream of charged particles called the solar wind. This wind travels at millions of miles per hour, creating a giant protective bubble around us called the heliosphere. Think of the heliosphere as a cosmic shield that deflects the harsh radiation of the Milky Way. Beyond this bubble lies the interstellar medium, the stuff between the stars. Scientists expected that the boundary where these two forces meet would be a quiet, gradual fading of one into the other. Instead, when the Voyager probes crossed this threshold, they didn't find a peaceful transition. They found a chaotic, high-pressure zone that shouldn't exist. They found a massive increase in temperature and a wall of hot, glowing hydrogen gas that seems to be trapped at the edge of our system. It's like sailing across a calm lake only to suddenly hit a brick wall of boiling water that was completely invisible until you touched it. One of the most baffling discoveries came from a satellite called IBEX, the Interstellar Boundary Explorer. In 2009, IBEX sent back a map of the edge of our solar system, and NASA scientists were stunned. Running across the sky was a giant, bright ribbon of high-energy particles. This ribbon is massive, stretching across a huge portion of the celestial sphere. But here's the kicker. None of our models of the magnetic fields or the solar wind predicted this structure. It's a narrow, intense band of energy that sits right on the edge of the heliosphere, and a decade later, NASA still admits they have no definitive explanation for why it's there or how it maintains its shape. It's as if someone drew a glowing line in the sand around our solar system, marking the territory where the sun's power ends and something else begins. But the mystery deepens when we look at the temperature data. As you move away from a heat source, things are supposed to get colder. That's basic thermodynamics. However, NASA's New Horizons mission, the same one that gave us those incredible photos of Pluto, discovered that the space at the edge of our solar system is actually getting hotter. There is an unaccounted-for source of energy that is pumping heat into the fringe of our system. Some scientists call this the fire at the edge, a region where the interstellar medium is being compressed and heated to extraordinary temperatures. This defies our standard understanding of how energy dissipates in a vacuum. It suggests that our solar system isn't just floating through empty space. It's plowing through a medium that is pushing back with a force we are only now beginning to calculate. Let's talk about Voyager 1 and Voyager 2, the legendary twin probes launched in 1977. These are the only human-made objects to ever cross into interstellar space. When Voyager 1 crossed the boundary in 2012, it sent back data that left researchers scratching their heads. It detected a massive surge in cosmic rays, which was expected, but the magnetic field didn't change direction the way the models said it would. It was as if the probe had entered a magnetic highway, where the rules of the solar system still applied. But the environment was totally different. It took Voyager 1 several years to truly break free, and even now, the signals it sends back are filled with anomalies. The instruments on these old probes were designed in the 70s, and they are now witnessing phenomena that modern supercomputers can barely simulate. The hydrogen wall is perhaps the most visual mystery. Imagine a vast glowing cloud of hydrogen atoms piling up at the edge of our solar system. This wall is formed as the solar wind crashes into the local interstellar cloud. It's like a traffic jam at the galactic scale. We first detected hints of this wall back in the 90s with the Hubble Space Telescope, but it wasn't until New Horizons confirmed the ultraviolet glow of this wall that we realized how true it was. This wall is a barrier that filters the light coming into our system from other stars. It changes the colors of the universe we see from Earth. Without this wall, our night sky might look entirely different. But why the wall is so dense and why it appears to be moving remains a mystery that current astrophysics cannot fully resolve. This brings up a fascinating question. Is our solar system special? When we look at other star systems through the eyes of telescopes like James Webb, we see similar bubbles around other stars called astrospheres. But the specific ribbon and hydrogen wall we have found at our edge seem to be unique to our current location in the galaxy. Our sun is moving through a region of space called the local interstellar cloud. We've been in this cloud for thousands of years, and we are due to exit it in another few thousand. Scientists are wondering if the anomalies we are seeing are a result of our sun colliding with a specific patch of space dust, or if there are invisible magnetic structures in the galaxy that we simply cannot detect yet. It's like our solar system is a submarine traveling through an ocean, and we've just hit a current that we didn't know was there. The scale of these discoveries is hard to wrap your brain around. Voyager 1 is currently over 14 billion miles from Earth. At that distance, a radio signal, even traveling at the speed of light, takes nearly 24 hours to reach us. Every piece of data we get from the edge is a message from the past, describing a place that no human could ever survive in. But the data tells us that the universe is far more interactive than we thought. It's not just empty space. It's an active, churning environment of magnetic fields, gas clouds, and energetic particles. The edge of our solar system is a battlefield where the sun's influence is fighting to keep the galaxy at bay. NASA's announcement about these unexplained findings has sparked a new era of fringe science. Some researchers are looking into the idea of dark matter playing a role at the edge of the heliosphere. Since we can't see dark matter, but we know it has a massive gravitational influence, could it be concentrating at the boundaries of star systems? While this is highly speculative, the fact that the ribbon has no other explanation means that every possibility is on the table. It's a reminder that we are still in the age of discovery. We might think we have the universe figured out, but we've only explored about 0.0001% of it. The edge of our solar system is our own backyard, and we just found a keep out sign that wasn't there before. Let's dive deeper into the New Horizons data. This probe is currently flying through the Kuiper Belt, a region filled with icy leftovers from the birth of the solar system. New Horizons is using an instrument called the ALICE UV spectrometer to look for the glow of the hydrogen wall. What they found was that the wall stays consistent no matter which direction the probe looks. This suggests that the wall isn't just in front of us. It might be a shell that completely surrounds us. This bubble of fire is a protective layer, but it's also a mystery. If the wall is a shell, what is providing the pressure to keep it spherical? If it were just the sun's motion, it should be shaped like a wake behind a boat. The fact that it's more symmetrical than expected suggests an external force is pushing back on all sides. This raises the Pioneer anomaly again. Back in the 80s and 90s, the Pioneer 10 and 11 probes seemed to be slowing down as they left the solar system. For decades, this was a massive mystery that people thought might require new physics to explain. It was eventually attributed to the way heat was radiating off the probe's batteries, pushing them slightly backward. But now, with the New Horizons and Voyager data, some scientists are revisiting the idea that the medium at the edge of space is thicker or more resistive than we anticipated. There is a sense in the scientific community that we are missing a piece of the puzzle, a hidden variable in the interstellar medium that makes travel through it more complex than we thought. Think about the solar cycle. Every 11 years, our sun goes through a period of high and low activity. During solar maximum, the sun is angry, spitting out flares and coronal mass ejections. This causes our heliosphere bubble to inflate like a balloon. During solar minimum, the bubble shrinks. NASA has observed that the ribbon at the edge changes along with this cycle, but with a delay. It's as if the edge of our solar system is an echo chamber, reflecting the sun's activity back at us with a years-long lag. By studying this breadth of the solar system, we are starting to realize that we are connected to the interstellar medium in a deep, rhythmic way. We aren't just an island, we are part of a breathing, galactic organism. Another baffling detail is the magnetic reconnection happening at the boundary. Magnetic reconnection is a process where magnetic field lines snap and realign, releasing massive amounts of energy. This is what causes solar flares. But NASA has found evidence that this is happening at the very edge of our solar system, where our magnetic field meets the galaxies. This creates magnetic bubbles that are tens of millions of miles wide. Voyager 1 and 2 actually flew through some of these bubbles. Imagine flying your spaceship into a giant magnetic foam. This foam acts as a secondary shield, trapping cosmic rays and preventing them from entering our system. But the physics of how this foam forms at such great distances is still being debated in peer-reviewed journals. The edge is also where we find the termination shock. This is the region where the solar wind abruptly slows down from supersonic to subsonic speeds. It's like a sonic boom, but for the wind of the sun. When the Voyagers crossed the termination shock, they found that the solar wind didn't just slow down, it became a turbulent, hot mess. The temperature of the ions in this region was much lower than predicted, which means the energy was going somewhere else. Where did it go? NASA scientists think it might be transferred to pick up ions, neutral atoms from the galaxy that get ionized and swept up by the sun. But the math doesn't fully add up, leaving a missing energy problem that continues to haunt the datasets. As we look toward the future, NASA is planning a new mission called the Interstellar Probe. This spacecraft would be designed to travel much faster than the Voyagers, aiming to reach a distance of 1,000 astronomical units in 50 years. This mission would be specifically designed to image the hydrogen wall and the ribbon from the outside. Looking back at our solar system, it would be our first selfie from across the interstellar void. Until that happens, we are like people trying to describe the exterior of a house while standing in the living room. We are looking through the windows of our telescopes and probes, trying to make sense of the blurry shapes and strange lights on the lawn. The fact that NASA is so open about these unexplained findings is a good sign. It shows that science is working. When the data doesn't fit the model, you don't throw away the data, you build a better model. These discoveries at the edge are forcing us to rethink the history of our solar system. If the environment outside our bubble is so much more intense than we thought, how has it affected life on Earth over the billions of years our system has traveled through the galaxy? Could transitions between different interstellar clouds have triggered ice ages or mass extinctions? The edge of the solar system isn't just a place for physics junkies. It's a record of our journey through the stars. Let's talk about the Voyager interstellar mission. To this day, these probes are still sending back signals. They are powered by decaying plutonium, and their power supplies are slowly fading. In a few years, they will go silent forever. But until then, every bit of data is precious. Recently, Voyager 1 had a computer glitch that made it send back a nonsense pattern of ones and zeros. It took months for NASA engineers to figure out that a single chip had failed and to bypass it. This successful remote surgery from 15 billion miles away is a testament to human ingenuity. It also means we are still getting live updates from the interstellar frontier. Voyager 1 is currently reporting that the density of the interstellar medium is actually increasing the further away it gets. This was a total surprise. Most people expected it to level off, but it seems we are heading into a thicker patch of the galaxy. What exactly is the interstellar medium? It's a mix of gas, dust, and cosmic rays, but it's also filled with the afterglow of long-departed stars. When a star goes supernova, it sprays its innards out into space. Our local neighborhood is filled with the remnants of these ancient explosions. The hydrogen wall at our edge might be a collection of this ancient debris, piling up against our sun's shield. This means that when we study the edge of our solar system, we are literally studying the remains of the stars that lived and passed away before our sun was even born. We are at the crossroads of galactic history. The no scientific explanation part of the NASA announcement specifically refers to the anomalous cosmic rays. These are high-energy particles that seem to be accelerated at the edge of the solar system, but they move in directions that defy the magnetic field lines. It's like seeing water flow uphill. There is a mechanism of acceleration out there that we haven't discovered yet. Some theorize it's a form of stochastic acceleration, where particles bounce back and forth between magnetic turbulence. But the energy levels are so high that some researchers think there might be something else out there, some kind of galactic wind or a nearby source of power that is interfering with our system. Then there is the Voyager 2 discrepancy. Voyager 2 crossed the boundary at a different location and time than Voyager 1. It found the wall was at a different distance and had a different thickness. This means our heliosphere isn't a perfect circle. It's dented or squashed. We think this is because of the galactic magnetic field pushing on us harder from certain angles. Imagine trying to hold a balloon in a strong wind. the balloon will deform. Our solar system is that balloon, and the wind of the Milky Way is trying to crush us. Understanding these dents is crucial for predicting how our system will respond as we move into new regions of the galaxy. Another strange discovery involves the neutral atoms that manage to leak through the hydrogen wall and into our solar system. NASA's IBEX mission tracks these atoms, and it has found that they are coming from a direction that doesn't match the motion of the sun through the galaxy. There is a mismatch of about 4 to 5 degrees. In a cosmic sense, that's a huge gap. It's like walking forward but feeling the wind hit you from the side. This suggests that the interstellar medium itself is flowing in a way that we don't understand, or that there is a massive, invisible object nearby, maybe a hidden brown dwarf star or a concentration of dark matter, that is gravity bending the flow of atoms into our system. Space is big, and the edge of our solar system is unimaginably far away. But it's not just a wasteland. It's a dynamic, glowing, pressured, and energetic frontier. The fact that we have found structures like the ribbon and the firewall proves that the universe is always more complex than our current theories allow. NASA's recent announcements aren't an admission of defeat. They are an invitation. They are telling us that the old maps are no longer enough. We need new physics, new probes, and new ways of seeing. Think about the voyage itself. These probes are the first ambassadors of humanity. They carry the golden record, a gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. They are sailing past the hydrogen wall, through the ribbon, and out into the eternal light. They are proof that we were here, but they are also our scouts. They are warning us that the gate to the galaxy is a fiery, magnetic barrier that we are only just starting to comprehend. The ribbon, the wall, the fire, the dents, it all points to a single conclusion. The solar system is a shelter. We are living in a protected pocket of space, shielded by a sun that is working overtime to keep us safe from the galactic chaos outside. Every bit of data from the edge is a reminder of how fragile and lucky we are. Our little bubble is moving through a violent and beautiful galaxy, and we've just discovered that the walls of our home are far more interesting than we ever dreamed. As NASA continues to analyze the data from New Horizons as it travels further into the Kuiper Belt, and as the Voyagers send their final whispers from the void, we are standing on the edge of a new understanding. We are realizing that the boundaries of our world are not fixed lines on a map, but interactive zones of mystery. The edge of the solar system is the ultimate frontier. It is the place where the sun's story ends and the galaxy's story begins. And based on what we've found so far, the galaxy has a lot of explaining to do. NASA's announcement is a call to look up and realize that the dark space between the stars is anything but empty. It's a place of unexplained wonders, of glowing walls and energy ribbons. It's a place that challenges our intellect and inspires our imagination. We started this journey in 1977 with a couple of probes and a dream of exploring the outer planets. We never expected that we would find a fire at the edge or a magnetic foam. We never expected that the vacuum of space would be so loud with the echoes of ancient stars. We are living in a golden age of space exploration. From the rovers on Mars to the telescopes looking at the first light of the universe, we are uncovering the secrets of our existence. But the data from the edge of our solar system is perhaps the most humbling. It tells us that even in our own neighborhood, there are mysteries that have no scientific explanation. It tells us that the universe is vast, mysterious, and beautiful, and it's waiting for us to catch up. So, the next time you look at the night sky, think about the hydrogen wall. Think about the ribbon of energy stretching across the void. Think about the Voyager probes, billions of miles away, feeling the heat of the galactic medium for the first time. The edge of the solar system isn't a dead end. It's the beginning of the next great chapter in human history. We've found the wall. We've found the fire. And now, we have to find the answers. The universe doesn't have a manual. It only has clues. And NASA just found the biggest clues yet. The edge of our solar system is speaking to us in the language of magnetic fields and energetic particles. It's telling us that we are part of something massive, something chaotic, and something wonderful. Our solar system isn't just a collection of planets. It's a traveler in a sea of fire, and we are just now getting to see the waves. The edge of space is closer than we think, but it's further than we can imagine. It's a place where the sun's light fades and the galaxy's secrets begin. We have crossed the threshold, and there is no going back. The unexplained findings from NASA are not just data. They are an invitation to the next generation of explorers, scientists, and dreamers. The wall is there. The mystery is real, and the journey into the interstellar unknown has finally, truly begun. Stand tall, Keep your eyes on the stars, and remember that even at the edge of everything, we are still discovering who we are. The solar system is a miracle, and its edge is the ultimate proof of how much more there is to see. Exploration is in our DNA, and the hydrogen wall is just the next hurdle. Stay curious, stay amazed, and stay tuned to the silence of the void, because it has a lot more to tell us. This is the new frontier, and it's open for business. The edge of our world is the beginning of our galaxy. Let's see what else is waiting out there.